Hello everyone. Let's continue our topic dimensional analysis. In the last class we saw what are the seven fundamental physical quantities and what is their dimensional expressions. We also saw one of the three applications of dimensional analysis in the conversion of units. In this video we are going to see how to check the consistency of any given equation with the help of principal homogeneity by using the dimensional analysis. And in the last and second part of the video, we will be establishing relation between different physical quantities with the help of dimensional analysis. This is the second application, that is checking the correctness of any formula or consistency of any given equation. Let me see whether is it clear or not. Okay. This principle, consistency principle or consistency of an equation is based on the fact that terms having same dimensional expression can be added or subtracted. What is the meaning of this statement? Let me make it very clear with the help of an example. Let's say I have an expression s equal to ut plus half at square. In order to check the consistency whether the given equation is consistent or inconsistent, all the terms, how many terms are there in this given equation? 1, 2 and 3. All the three terms must have same dimensional expression. We will treat all the terms as individual terms and we will also ignore this half or any constant or any number. So S is displacement, U for initial velocity, E for time, A for acceleration. So these are the three terms. They all must have same dimensional formula. Displacement is a type of length. UT, dimensional formula of U, that is velocity. So LT minus 1 multiplied by time. Dimensional formula of acceleration, LT minus 2, and for time T power 2. Let's check. So T to be cancelled and here this one is also cancelled. So all the three terms have same dimensional formula. That is why this given equation is consistent. Let's take another example. Check whether given equation u v is equals to u plus at is consistent. So v, there are three terms total, 1, 2, 3. Let's find out their dimensional expression. If they are same, then given equation is consistent. V for velocity, U for again initial velocity, at acceleration multiplied by time, acceleration multiplied by time. So Again this becomes LT minus 1. Here LT minus 1, that is LT minus. Again this given equation is consistent because all the terms have same dimensional formula. Let's take one more example. In total there are three terms in the given equation. LT minus 1, that is the dimensional formula of velocity, and power 2, whole power 2. LT minus 1 whole power 2 for initial velocity equals 2 will be ignored as it is a constant, only A and S, acceleration and displacement. So LT minus 2 acceleration into displacement. So this becomes LT minus 1. Here I have L square T power minus 2. Again I have L square T minus 2. Here it is L square, L into L square. So again L square T minus 2, L square minus T minus 2. Here L square T minus 2 as it is minus 2 here. Minus 2. This equation is consistent again. This is a question. Check if the given equation is dimensionally consistent or not. So if dimension on both the sides is same, then this is going to be a consistent equation. Ignore this half. So dimension of mass is M and of velocity LT minus 2 whole square. Mass multiplied by gravitational acceleration, whose dimensional formula is LT minus 2 into height, a type of length. So this becomes M L square T minus 2. Here it again M L square T power minus 2. Both sides have same dimensional expression, so the given equation is consistent. Let's take one more question. Check whether both the equations are dimensionally correct or not. Are they consistent or not? Again, same process. Let's solve the first question. Lambda is wavelength and h is Planck's constant, and formula for Planck's constant is, first we will have to find out dimensional expression of individual term, individual physical quantity. Let's say there is a constant, that is Planck's constant h. So in order to solve, in order to check whether the given equation is consistent or inconsistent, we should have idea about the dimensional expression of Planck's constant h. So let's find out. H is equals to energy. Planck's constant equals energy upon frequency. Energy upon frequency. This is the that what we call as formula of Planck's constant. So for energy and work, same dimensional formula, that is m L square T minus 2, and frequency means 1 by time period. Frequency means 1 by time period. Is it visible? Yes. So 1 by t means dimensional formula of frequency will be t power minus 1. To solve it, we are going to have m l square t power minus 1. This is the dimensional formula of Planck's constant. Let's put it in the equation. I will erase this part. Let me shift it here. Now, lambda equals h upon mb. Lambda is the wavelength, so dimensional formula is L. Dimensional formula of Planck's constant ml squared t minus 1 divided by mass into velocity lt minus 1. Solve it. So m to m cancel. L power 2 t power minus 1 to t power minus 1 again cancel, divided by L power 2 by L. So this becomes L. So the given equation is consistent. This equation is consistent. Let's solve this second equation. Let me erase this. Again the same funda, that we will have an idea about the dimensional expression of different used terms. So let's find out dimensional formula of universal gravitational constant, that is capital G. So basic formula is F is equals to G times M1 M2 divided by R square. Hence G equals FR square divided by M1 into M2. Dimensional formula of force ML T minus 2. And dimensional formula of radius square, radius is a type of length, so L square divided by mass into mass, M square. So this becomes m power minus 1 and L cube and t power minus 2. This is the dimensional formula of capital G. So let me erase it. Now let's solve this equation. Dimensional formula of velocity Lt minus, let me write it here, Lt minus 1 equals under root 2 will not be counted, only G, and the dimensional formula of G is into mass divided by length. So this m power minus 1, m power plus 1. So this will cancel out. Now I have L power 3 divided by L. So L square divided by t power 2. I shifted this t power minus 2 in denominator. So this becomes L by t. That is nothing but Lt minus 1. So Lt minus 1, and here also I have Lt minus 1 on the left side. So this given equation is again consistent. Consistent. I have a new question. Find dimensions of a by b in the equation f is equals a root x plus dt square, where f is force, x is distance, and t is time. If I suppose this given equation is consistent, then the dimensional formula of all the terms should be same. So dimensional formula of force is mlt minus 2. Dimensional formula of A is unknown, and dimensional formula of under root x is under root n, equals B into time, that is t square. Let's compare A root x with ml t minus 2. So basically this is A root n. So A is nothing but m l t minus 2 divided by L under root. So this becomes m l 1 minus half. When we will take out it under root L in the numerator, then it becomes minus half power, and t power minus 2. So dimensions of A is m l power half e power minus 2. This is the dimensional formula of A. Now, dimensional, let's compare last part with ml t minus 2. So, bt square equals ml t minus 2. So, b equals, so this becomes b equals m l t power minus 2 minus 2 minus 4. This is the dimensional formula of b. Hence, dimensional formula of a by b. Let this equation number 1 and equation number 2. So a by b means equation number 1 by equation number 2. So equation number 1 is ml half t minus 2 divided by m l t minus 4. Mass to mass cancel. So this becomes L power half minus 1, as this L will go in the numerator. So, and this t becomes t power 2 minus 2 plus 4. So a by b becomes L power minus half and t power 2. So this can be expressed as uh, t power 2 divided by under root L. So this is the dimensional formula of a by b. I hope till now things are very much clear in your mind. First, we saw what is the semi-fundamental physical quantities and their dimensional expressions. Then after we also saw dimensional formula of different physical quantities. In the last part of the first video, we saw what is the application in the conversion of units. And in this particular video, today we are witnessing what is the second application of dimensional analysis in proving the given equation consistent. If all the terms have same dimensional formula, then only the given equation will be consistent. Otherwise, if any of the many terms is containing different dimensional formula from rest of the terms, then the given equation will not be consistent. Actually, any equation is correct or incorrect is based on the fact that all the terms should have same dimensional expression. Only the terms having same dimensional expression can be added or subtracted. So that's why this consistency of an equation is based on the principle of homogeneity. And we saw how to check the consistency of the equation in first or in two or three questions. Then after we also saw if any question is given and it is also explicitly mentioned in the question that the given equation is consistent. So probably you would ask what will the dimensional formula of any unknown like a and b. So what we will have to do, we will have to first consider the fact that the given equation is already consistent. We will not have to prove that. That is already consistent. That we will have to assume as per the question. So if let's suppose this is asking for dimensional formula of A and B. So we will have to make the dimensional formula of all the terms equal. Then we will do the comparison. We will make two equations out of this particular expression and we will find out the dimensional formula of A and B individually and then divide them A by B and we will have the answer that is a dimensional formula of A by B. So this is how we tackle the questions. Now let's discuss the last application of dimensional analysis, that is in establishing the relation between different physical quantities. Deducing relation among the physical quantities. This is the third application of dimensional analysis. So deducing relation among physical quantities is based on the fact that first we will have to look up to the factors on which a given physical quantity depends. If we are well aware of the factors on which a given physical quantity depends, then definitely we can have the dimensional formula of the given quantity also. With the help of principle of homogeneity, we can also find out the values of powers A, B and C. And once we derive the values of powers A, B and C, we can put it in the equation and finally we will have the formula. Let's understand the concept with the help of an example. Question is, we have a question, derive an expression for centripetal force capital F acting on a particle of mass small m moving with a velocity v in the circle of a radius small r. So basically we are asked to find out the expression for centripetal force capital F. This centripetal force depends on the factor mass, radius, and that's it. So there are two factors on which centripetal force depends. One is mass and second is radius in which mass is revolving. So first we will have to write it in such a manner like F is directly proportional to factor first is mass power A and factor second is radius power P. Formula or expression that we are going to calculate, let's say we are asked to find out the expression for centripetal force. So write it on the left side and factors on the right side and put the powers of mass and radius. Put the power on the factors and use the sign of proportionality. So in order to remove the sign of proportionality, we add a constant K times M power A R power B. Do you know the dimensional formula of centripetal force? Because centripetal force is also ultimately a type of force only. So dimensional formula of centripetal force will be same. That is mLT minus 2. Dimensional formula of mass m power A. And dimensional formula of radius is length L power T. Let's make a comparison. M power 1, M power A. So value of A is 1. What I am doing? I am doing a comparison of powers. So A is equals to 1. Second, L power 1, L power B. So B is 1 again. Here, as such, there is no term. I have time. Time is T power minus 2 and here T power 0. So please pardon me. This centripetal force depends on three factors. One is mass, velocity, and radius. So let me correct it. Centripetal force depend on three factors: mass, radius, mass, velocity, and radius. Let me make it again clear. Centripetal force depend on three factors: mass, velocity, and radius. Put the centripetal force on the left side and on the right side factors on which centripetal force depends. Then put parts of mass, velocity, and radius. Remove this sign of proportionality with a constant K. K is constant. Write the dimensional formula of centripetal force. That is a type of force. So dimensional formula is mLT minus 2. So K for mass m power A. For velocity LT minus 2. LT minus 1 into radius. Radius is a type of length. So L power C. So this can be written as m power A, L power B, and L power C. So L power B plus C and T power minus B. Here I have M L T minus 2. Let's compare mass with mass, length with length, and time with time. So m power 1, m power A. So A is equals 1. Second, L power 1, L power B plus C. So B plus C is equals 1. T power minus 2, T power minus B. So minus B equals minus 2, B equals 2. So from here, let's put the value of B. So 2 plus C equals 1, C equals minus 1. Now let's put these values in the first equation. This is the first equation. So F is equals K times M power A, and A means 1. V power B, so V power 2 divided by where is R? R power C. So R power minus 1. So this can be expressed as F is equals K times MB square divided by R. So this is the expression of centripetal force, K times MB square divided by R.